All right, today we're going to be looking at factoring polynomials. This is lesson 0-3 on page P7 in the Algebra 2 book. Just a reminder that you can pull this up on your ebook, so you don't just have to have a class set of text. You can look this up. Another reminder, if you're seeing any terminology you're not familiar with, you can, if it's a yellow word in the book, you can look in the glossary. No word, you can just Google it and find out what's going on. All right, so as we factor, we got to understand that we're probably dealing with at least two terms, sometimes up to four and even more, but today we're going to look at 2 and 3 terms that we're going to factor. So we're going to jump into example 1, all right? So this says to use the distributive property and factor 4a squared plus 8a. So when it's two terms, the first thing you're always going to do when you factor is find a GCF, a greatest common factor. And then after you do that, your second step is to actually factor the problem. All right, so as we look at 4a squared plus 8a, this is two terms. The plus sign splits this up into two terms. Now I need the biggest number or the biggest multiple of 4 that's also a multiple of 8, and I pull that out and set up the distributive property. All right, so what number goes into 4 into 8? Well, that's obviously 4. I'm going to take the biggest number or the biggest factor that goes into both of those. I'm going to do a GCF for both the a squared and the a. I need the biggest amount of variables that we can find. This has 2 a's, this has 1. The biggest that both of them have is 1a. So there's my GCF, that's 4a. And now I'm going to set up the distributive property because this is two terms. So remember distributive property. I'm going to take this and multiply it by something to get back to that first term. So 4a times something will give me 4a squared. I need to plug in regular old a because 4a times a is 4a squared. I need to do the same thing to the second term. Again, it's just distributive property that we're setting up. 4a times what is positive 8a? Well, 4 times positive 2 would give me 8. A times 2 obviously still leaves that a there. I don't need to put in a. And so my final answer with the GCF right here is 4a times a plus 2. And I can leave that alone. And so that's a two-term problem that we just factored. All right, let's jump down to example 2 and get into the stuff that you probably think of when you think of factoring. All right, it says factor each polynomial. I'm right here in the middle of the page. And we're going to take x squared plus 5x plus 6, and we're going to factor that. All right, so you need to know that when this is a three-term problem, this is quadratic because it's x to the second power. Standard form for this says that we have ax squared plus bx plus c. You may not remember that. That's just saying, hey, this is quadratic. Here's what we're looking to do. I'm looking for factors of c, things that multiply to get c, that add to get b. C is the constant, b is the number with the linear term. So I'm going to come out here again. I'm looking for factors of c, all right? And then we want to see which of those add or subtract to get b, the number in front of the linear term or the x term. So you got to understand, factors is multiplication. Then we're going to look at the addition and subtraction of it. So for this problem, I need to look at factors of 6. Now that's pretty easy, but let's say you're not good at it. We're going to go to the calculator, and here's how you can find factors. All right, I'm going to go in. Let me get it where you can see it. Clear out what's there. I'm going to go to y equals. I'm going to put the number I'm trying to factor in, so 6. I'm going to divide it by x, and then we're going to go to our table, so second graph. All right? Well, 6 divided by 0 doesn't exist. That's why it gives you an error. And then it starts listing out factors. Factors are whole numbers. So I'm going to move this over and write them down. So to get to 6, I know that I can do 1 times 6. If I keep going down, the next one is 2 times 3. Now, if you'll notice, the next one is 3 times 2. Well, that's the same as that, just flip, so I'm done. Kind of one more thing to show you. 4 is not a factor of 6 because it doesn't have a whole number buddy that goes with it. Yeah, 4 times 1.5 is 6. I'm looking for whole number factors. So I have the two factors that make up 6, 1 times 6 and 2 times 3. Now I need to look at, hey, which of these two add to get 5? Well, 1 plus 6 isn't 5, it's 7. What about 2 plus 3? Absolutely. Those are the two factors I need. Now we're setting this thing up and going to write it like FOIL that you learned when we did 0-2. And so as we look at this now, I got to remember my first terms multiplied together in this instance have to give me x squared. I am then going to plug in the factors. Since I knew what the signs were, I know that it's going to be positive 2 and positive 3. And so that is this thing factored. The bottom line, we can check it quick and make sure we're right. When I FOIL, x times x is x squared. Outer, x times 3, positive 3x. Inner, 2 times x, positive 2x. Last, 2 times 3 is positive 6. When I combine that middle term, I get x squared plus 5x plus 6. Is that the same as where we started? Yes, it is. I know that that represents the two factors of the example. And this again was example 2, and that was actually part A. All right, so let's go jump down. Let's keep going. Let's go to example 2, part B. Right here on page P7 that says x squared minus 8x plus 12. All right, as we deal with that, kind of jumping a little bit faster. I am looking, first of all, our rules say when we factor to look for a GCF. I don't have one. We'll keep that pretty easy on you today. All right, so I'm going to look for factors of 12 that add to get negative 8. So we've got to be a little bit careful. Let's go back to the calculator. I'm going to do 12 divided by x. I'm going to do second graph and go to the table. Now right here, all right, if I do 1 times 12, that's never going to get me a negative. So I know that if my sign here, if I'm trying to get positive 12 but adding to get a negative, 1, 12, 2, 6, none of those work. If you add any of those, they stay positive. So we got to go to the negative side. There we go. Now negative 1 times negative 12 will add, all right, to get negative 13, but it'll multiply to get 12. So we want to multiply and get positive 12. This just isn't the right factor. Let's keep going. Negative 2 times negative 6. All right, I'm going to show you the rest of them, but we just found our answer, right? So I got negative 3 times negative 4. Negative 4 times negative 3. There they go. They start repeating again, so I'm done. And again, just another review. Negative 5 times negative 2.4 doesn't do anything for me because I need whole numbers. Well, now as I look at these, and again, remember the order can flip. I have found the pair, all right, that multiplies to get 12 and adds to get negative 8. It's negative 2 and negative 6. So I now can go set this up. That becomes x minus 2, x minus 6 are my two binomial factors. A quick FOIL check. X times x is x squared. Outer gives us minus 6x. Inner gives us minus 2x. Negative 2 times negative 6 is positive 12. Combine my like terms, I get x squared minus 8x plus 12. All right, we know that those factors were the right answers. If you feel comfortable with it, you don't have to check it. But if you don't, it is smart to check it because you can know if it was right. All right, let's jump down here. Look at another sign change. Example C. X squared plus 14x minus 15. So now the negative sign is with C. So that's going to change the signs when we do our factors in a second. First thing I check for is GCF. Remember, a number in front of x squared, if there's nothing there, it's assumed to be 1. So 1, 14, and negative 15 don't have a GCF that I can pull out. All three terms don't have at least the same variable, so I've got to leave it alone. So now we're going to look at factors of negative 15. I'm going to go to the calculator. I'm going to do negative 15 divided by x, all right? When C is negative, you got a little bit more thinking to do. I'm going to go back and start at 1 right there. So I'm going to write them down. I have 1 times negative 15. You have to know that I can flip those signs, and I can also do negative 1 times positive 15. Both of those are factors. Now they're here. They're just on either side of the table. You got to pay some attention. 2 is not a factor of negative 15. I have 3 times negative 5, and I've got to remember I could also have negative 3 times positive 5. So you got to be able to flip those signs and know that. 4 is not a factor. Now when you get to 5 and negative 3, I've already got it written. So we started repeating, so we know that we're done. All right? We know that we're finished. Now we need to find the factors that add to get positive 14. Well, it's definitely not either of these. That adds to get negative 2. That adds to get positive 2. So let's look. 1 plus negative 15 is negative 14, but here we go. Negative 1 plus 15 gives us positive 14. If you're not good with adding negatives, use your calculator. That's fine. And we're going to come write it out as x minus 1 times x plus 15. Again, a quick check. X times x is x squared. We're foiling. Outer says x times 15 is positive 15x. Inner, Negative 1 times x is negative 1x, or we can just write that negative x. Remember that? Negative 1 times positive 15, there's our negative 15. Combine like terms, middle are like terms, x squared I leave alone, plus 15x minus x is plus 14x, and then my constant is negative 15. These are the factors, all right? Let's see what we got going on here. Okay, we're going to jump ahead. Now what happens when you get a number in front of x squared? I'm going to teach you this, and it's something that I think that you can be pretty successful at. All right, so I am now at example 3, and I've got this. I've got 6x squared plus 7x minus 3. All right, so to work this, I've seen this done several ways. You can guess and check. That's kind of the old school method, but there's a way that I like. So when I'm going to do this, we're going to check for a GCF first. 6, 7, and 3 do not share a common factor, so we're good. I don't have a variable in every term, so I don't have a GCF. All right, so here's the steps here. Now remember, standard form for us in a quadratic equation is ax squared plus bx plus c. When I do this, here are your steps. The first thing you're going to do is multiply a times c, and then you're going to rewrite this problem. So I'm giving you some steps out here to the side. So a times c, that number is a, which is 6. C is negative 3. I'm going to multiply those together, and I'm going to rewrite this. When I do that, I take the 6 out of there, so I rewrite this. X squared, the middle term doesn't change, so it's still plus 7x. 6 times negative 3 is negative 18. So when I say to do a times c and rewrite, these are the steps. Do a times c, rewrite this. Now we're going to factor. So that's our next step, is to factor. All right? So we're going to look for multiples of negative 18 that add to get 7. So I'm just going to walk through them without the calculator. It could be 1 and negative 18 or negative 1 and positive 18. Do either of those add to get 7? No. I've got 2 and negative 9 or negative 2 and positive 9. Right? Again, you could do negative 18 divided by x in your calculator and y equals and check the table, but we just got the answer that we wanted. Which one of these adds to get 7? Those two factors right there, negative 2 and positive 9. So we're going to go write it out. That becomes x minus 2 and x plus 9. Now I can't put a box around these answers because that doesn't FOIL to get where we started, so we're not done. Now here's the next step. All right, I'm going to write this. Divide by a. And I'll show you what to do. We're going to take that original a, and I'm going to come to this step, and I'm going to divide the two numbers by that. So negative 2, I'm going to divide by 6. And 9, I'm going to divide by 6, okay? So after you divide by a, then you're going to reduce the fractions or fractions if you can. Well, this reduces to x minus 1/3. If you are not good at that in the calculator, all right, go to the home page and just do negative 2 divided by 6, and then do math, enter, and it'll change that fraction to negative 1/3 for you. So real easy to reduce in the calculator. So that's x minus 1/3, all right? Without the calculator, 3 goes into both of these, so 9 over 6 reduces to 3 halves. All right, at this step, I'm telling you, let me erase that and write that a little bit better. I'm telling you that you are not going to leave a fraction in your answer. So after we reduce, then you put the number in front of x, or these denominators become your coefficients. I'm going to call that moving the denominators. Now, if your denominator is 1, then it's fine. You have nothing to do. But we're going to move the denominators. That 3 is going to come right up here in front of the x. That 2 is going to go right there in front of that x. So these are what these factors look like now. 3x minus 1 times 2x plus 3. If we've done this right, I should be able to FOIL this and get back to where we started. Let's check. First terms, 3x times 2x is 6x squared. Outer, 3x times positive 3 is positive 9x. Inner, negative 1 times 2x is negative 2x. Last, negative 1 times positive 3 is negative 3. There's my like terms with the same last name, so I combine them. I have 6x squared, didn't have a like term, it stays there. Plus 9x minus 2x is plus 7x, and my constant is minus 3. Does that match the original? It sure does, and there we go. There is our factored answer. So it's a pretty nice way to do that. All right, I'm going to show you 2 more very quickly, and we're going to be done. Example 4. Okay, this is part A, and it says 4x squared plus 20x plus 25. We have a trick. If the ax squared and the c are perfect squares, write that down. Perfect squares, remember, like 2 squared is 4, 3 squared is 9, 4 squared is 16. So 4, 9, 16. Those are called perfect squares, all right? If you have perfect squares for A and C, we can try to take the square root of those and factor. And you're like, what? Here's what I mean. If the same thing times itself gives us 4x squared, I can try a shortcut, all right? That would mean that I would have 2x times 2x. Does that give us 4x squared? Yes. I can look at the constant, or my last term. If it's a perfect square, take the square root. What's the square root of 25? It is 5. I'm adding these because my middle term is positive, so I'm going to put pluses in there, and I'm just going to show you when we FOIL this, I get 4x squared plus 10x plus 10x plus 25. When I combine my middle term right there, I get 4x squared plus 20x plus 25. See how that plays out? That's exactly where we started. So you could do this like I did in the last example, example 3, or if you can recognize the pattern that I had 2 perfect squares, the ax squared and the c were perfect squares, I can try that little trick. Now, if you mess that up, my suggestion is to go back and try it like we did the previous example. All right, that's a 3-term that had perfect squares. Let's look what happens when we have a 2-term. If you have a 2-term problem and both are perfect squares, this is still ax squared, this is still c. If you will notice, b is 0. There is no linear term here. I can try to take the square roots of these and see if it works. Here's what I mean. The square root of x squared is x, so I can plug in my x's there because x times x is x squared. The square root of 4 is 2, so I plug in my 2's. Since this sign is negative, one of these needs to be positive, one of them needs to be negative. Now let's check and see if that's my answer by FOILing. First terms, x times x is x squared, outer is negative 2x, inner is positive 2x, last is negative 4. What do you notice about your middle terms right here? When I go add negative 2x and positive 2x, they cancel out. And I am left with x squared minus 4, which is exactly where we started. And so there are my factors of x squared minus 4. So it's kind of nice if you can recognize a pattern. With 3 terms, okay, it's going to have to be talking about addition. The only time you can factor like this with 2 terms is if they're both perfect squares and you're subtracting. If this was a plus sign, we would have to have another way. We wouldn't be able to factor this like we saw right here. So the first step of factoring is to find the GCF, all right, and then you factor. You got a bunch of examples today of how we're going to factor. Obviously, this probably doesn't cover all of them, but this definitely gives you a jump on factoring and reviewing that as we continue to move on.